Good evening once again. Today we want to quickly look at the logic of scientific reasoning. In the last lecture 2 days ago, I made mention of something like that. So by next lecture, we'll be able to go straight to statistics proper. We start with the basic concepts. But it's good for us to have this at the back of our mind because nobody does statistics for doing sake. There must be a reason, and the reason is for research. Whatever, there's no either small or big. So the reason for statistics is to to collect data and make deduction from it, and that is part of research. So statistics are an integral part of research. So how do we think? Because we're going to realize that statistics is technology of scientific method. And, what makes it like that is what we want to discuss this evening. So somebody said, that's Jules Henry Ponke, says science is built up with facts as a house with stone, but a collection of facts is no more a science than a heap of stone, a house. So when we go to the field to collect data, it's like gathering stone. So the stone is just like somebody that wants to build house. Gathering stone, putting them up, make a house until they are arranged in a thematic manner. Now it's the same thing. When we go to the field to collect data, we have to mute, please. Non-Jew, mute, please. Non-Jew, mute, disturbing the class. So when you collect data from the field, we have to organize. Before we can bring out information and knowledge, it must be organized and make
I'm on the lecture, but you can talk. So what can we do?
Non-Jew, please. Okay, I've muted the person. Yes, we just have to, organize it. That is what this person is saying. The purpose of science is to uncover the truth. Uncover the truth just means to know what works and what does not work. We are not talking of the truth in the context of in the truth as we know in our religion or our relationship with God, because we know that truth, when you say truth, it's only God that know the truth. It's only God that is true. But here now, what we just mean as truth is what work, what will not work. So that's essence of doing research. In solving problem in the society, what step should we take? If we do it like this, will it work? If we do it like it will not work. So sometimes if you do research, you not discover it will not work. At least you know that it will not work. What will work, you also discover. So that is the essence of science, is to uncover the truth. Now, for scientists, there are two sets of tools that scientists use, and they are the senses and ability to reason. Senses, what you use senses to do is to capture data. All this, when we go to the field to capture data, is senses we use. Senses. You want to collect data, you see somebody, you ask for the age. There's the person, you hear with your ear that, the person is 35 years old. So if you see the way the person dress, you may not need to ask what is the sex. It's okay, you assume this is a female, this is a male. At least you have used your sense, the sense of sight to know that. If you need to, we doctors, sometimes we may need to measure, we want to palpate, to feel something is hard or not. We use our touch, sense of touch. So actually collecting data, the senses is what we use to communicate with the world. We use to capture data, stimuli from the world. And that is how we perceive and we gather our data, the senses. Now, the next one is the ability to reason. So when we capture all this data now, how do we bring it together to generate information and knowledge? And that is what the statistics help us to do. So over the year, man has invented statistics to help in doing all this work, to reason. And that is where we need statistics, ability to reason. When you gather information, you reason and are not okay. This is what working, this is what is not working. And there are two types of relationship between scientific mind and the world. Now, you have captured data as a scientist. You know, whether you measure something in the laboratory, you take sample, measure something's weight, diet, whatever we do, experiment we carry out in the laboratory, even on the field, we use our senses to capture, to record. But the reason now, so of course, that when we reason, we are using our mind. From what we have captured from the world, we use our mind to reason before we bring out information. So there are two types of relationship between the scientific mind and the world. Now, if you remember in those days, when we read our chemistry, physics book, they tell us that the scientific method, how does scientists understand the world? He said the scientists first of all make a guess. That's what they usually say, make a guess. The guess now, just for example, when somebody, Galileo, is it Newton that saw Newton that saw that fruit fell from the tree, and now there must be a force that brought that that made the fruit to move downward rather than sideways or upward. So they now begin. He made that guess that there must be a force. So now, so many times we see that they start with guess and now gather instrument, equipment to carry out research to, the guess is now stated in form of hypothesis. That is, hypothesis, you say that, oh, there is just a statement of relationship between two or more variables, two phenomena. Oh, for example, in case of Newton now, oh, there is a mass and there is a force that brings the mass down. So there is a relationship between the mass, that particular thing, and the force. That must be a force somewhere that brings it down. So sometimes also in a simpler way, we can say, oh, there is a relationship between salt intake and blood pressure. So this is a form of hypothesis. Since it has not been tested, that guess is stated in form of hypothesis. When it is tested and you discover that it's true that there's a relationship between those two variables, and if another person carry out the work and find out the same thing over and over, the hypothesis becomes theory. If it has been tested over and over, it becomes principle. By the time that nobody has actually refuted it, it becomes law. Just like the gravitational law now, it has been tested over and over and over, it has become law. So it started as guess and then theory, then principle, then became law. But if it was tested and it's not discovered that it's not true, so you say scientists, what it does is to maybe change the hypothesis again, maybe modify the hypothesis, and I find a way of proving that also. Now, for many years, scientists thought that this is the only way, and that way is what we call deduction. So if you look at it now, look at this arrow, deduction or prediction, or you predict or you make a deduction. So here now, you see from this diagram or from this picture, you see that the arrow is from general theory to observation, deduction. That is, this person, you start with theory. No, remember the theory is stated in form of hypothesis, just a relationship between two variables. It's stated in form of hypothesis. So you now try to gather data to prove if it is right or not. So by the time you make your generalization, we'll still talk about generalization. By the time you make your generalization from the study, and that's, oh, yes, there's a relationship between salt intake and blood pressure. The people that take much salt will likely, will be more likely to have high blood pressure or higher blood pressure than the other. So if you started with this theory or with the hypothesis, and you prove whether it's right or not, what you are making is deduction. So for many years, the scientists thought that is the only way, but the observation you see is data collection. That is, You start with theory, you make your observation, you collect data. And in statistics and research, observation and measurement actually mean the same thing. It means you collect data. You know, you see now, the way what I was saying the other time, if you want to collect data from somebody, you may have to ask some question. You may have to even observe maybe somebody's skin color. Even for doctors, sometimes jaundice, want to see, you look at the eye. So all those things is, you can say you make observation. But in a situation we say stand on the weighing scale, you measure blood pressure, you measure, sometimes you collect blood sample, you got a measurement. So in statistics and research, observation and measurement actually mean the same thing. Observation, but though in English it may not mean the same thing, but in statistics and research, it actually means data collection. Observation. So when we talk about observation, you collect data. Now, the scientists, over the year thought that the only way the scientists relate with the outside world is to make a guess, then try to prove, and then from there they get knowledge. Now, some people now thought over the year, after some time, look at even that guess. What will make somebody make a guess? It's an observation. Like before, look at Newton. He made an observation. Even that observation is a scientific method on its own. It's not everybody, something just fell. It's not okay. There are many people that be seeing that they never thought of what is making this fruit come down. So here, even that guess itself, ability to make that guess from observation, itself is scientific method. So the only thing that the guess can be, spurious. For example, now, what Newton made was a spurious observation. He didn't plan for it, he was just relaxing, thinking, and he just made the observation. That's spurious. Or maybe you are in your clinic, you now discover you are in your office. They say there are cases of teenage pregnancy, and you now, over the period of 1 month or 3 months, you now discover some of these cases of teenage pregnancy, they actually from a particular section of the community, or a particular group in the community. So you now say, look, it's like this is maybe if it's ethnic group, or maybe people that are living in a particular village, maybe it's a rural setting, it's a ghetto, you know, say, no, the place of residence actually, may determine if a child will have teenage pregnancy or not. That also is a spurious observation, because you are just doing your work. You were not thinking of it. As you are doing your work, you made that observation. So in that way, you make that guess. You may want to prove it by carry out study. Now, the observation may be systematic. Systematic in the sense that you decide to carry out a study. For example, all the descriptive study you do, is systematic observation you make because you plan it. For example, somebody say pattern of driving. I want to study pattern of driving in Abuja, or in Lagos. So when you say pattern of driving, so there you are not saying they are not making any guess that the people that have license are more likely to have accident or not, or women are likely to hit some people, or men are likely, or younger people are likely to drive rough, or many. Those are different guess. But you didn't make that. You didn't start with that. You just say pattern of driving in Lagos. In that situation now, of course, you do your literature review, you design your tool. There, you know that what are those things that are relevant for driving. Okay, you see age, sex, you capture, you have license, you have when did you go to driving school, all those things. You also ask questions. Have you ever hit somebody or scratched somebody, or have you ever had accident? You ask for many. If you have driving license, is it valid? At what age do you start driving? All those questions may be asked. By the time you now collect the data, you begin to think over the data, analyze it, reason over it. You will now discover that it's like the people that don't have license are more likely to drive rough, or the younger one are more likely to hit somebody. You begin to make those association or relationship between the variables you've captured. By making that association, you are generating hypotheses. So when you generate, imagine now you publish the work and I say, people that don't have license are more likely to have accident or hit somebody while driving. You have made the theory. So somebody may now come on and now pick it up and I say, is it actually true? But that one will now start with hypothesis that, oh, it's looking at the relationship of license, having license and having accident, something like that. So, but that particular, you have made a generalization now from observation you have made. So that is induction. You infer induction. Can you see now? From either spurious or systematic observation, if you are able to make a general theory, generalization, and have a statement that, oh, that specify a relationship between two phenomena, and that is from your observation, that is induction. It's a scientific method also. So that's why when you are carrying out descriptive study that is not analytical, you are when you are making your generalization, you are concluding what you are doing is induction. Because at the end of the day, you from your observation, you're able to say, or give some relationship, statement of relationship between some variables you have measured. So if you publish them now, another person will now pick it up. And that's is it actually true that people that take much salt are more likely to have high blood pressure? Somebody will not study it. Can you see? So the research, development of science take these two forms. So people will pick the result of induction and now use to carry out a study and now make the, and from the deduction, whatever people make observation also from deduction, from the outcome, and try to do some study, descriptive study also, that will generate some hypothesis. Let's give an example now. For example, if you remember for many years, some of us that are doctors here, for many years, randomized control trial have been done to specify to establish the relationship, the role of low dose aspirin in reducing death from cardiovascular disease. And for many years, people have been prescribing low dose aspirin. For people to do that, they might have made some, start with maybe some people have made some observation. Later, they now say, okay, what is the relationship? Does aspirin reduce death from? It's an analytical study. To do that, you have to do randomized controlled analytical study. So you just it's from a theory. You are testing an hypothesis, and at the end of the day, they establish it. They validated many times that it has been useful in reducing death from cardiovascular disease. So that many people started prescribing aspirin, low dose aspirin, until some people now made some observation also. Can you see? They made also that some of these people, people die, even more people die from bleeding disorder, from the aspirin, than they will have even die from cardiovascular disease. So it was an observation. Sometimes when you carry out randomized control trial to establish the usefulness of a particular treatment or drug, you need some study also to know the effect of the drug. So in the society, just to know, this one is it will be a descriptive study to actually know, the effect of this drug in the society. But from that you may actually make some hypotheses that some people will now test with analytical study. Can you see now? So deduction, induction, that is peculiar to descriptive study. Why deduction is conclusion you make when you carry out analytical study. And that is in science, in any field, not only in medicine, any field, engineering, any field of science. Those are the two, that is the relationship between the mind of a scientist and the outside world. So all the research you are doing is either you are, in your conclusion, you are making an induction or you are making a deduction. It's either it's descriptive or it's analytical. Now, I just use this, what do I call it? This diagram to explain. I think we can still shed more light on it. In inductive inference, okay, before I talk about the inference now, inference is just a generalization you made from sample to the population. So in our next study, we are going to talk about population, how it relates to sample, and how, the reason for taking sample. Now, when we don't study the whole population, most of the time we don't study the whole population, because the parameter, the phenomenon of interest is in the population. You are concerned about solving problems with population. That's why you are doing research. So that's why population is fundamental. And most of the time, you cannot attend to the whole population and make your observation on all the elements in that population. You take sample. So the issue now is that when you take a sample, you conclude your study, you make a generalization, blank statement. Can you imagine? Maybe Dr. Yakpo carry out a study in Lagos among maybe market women, and about maybe lifestyle, obesity, and that's all. And I conclude that, 25% of the market women in Lagos, they are obese. So if you look at it, he has done the study in Lagos and maybe selected one or two markets. There are many markets in Lagos. They randomly select one or two markets, and maybe sample about 600, 400 to 600 people, women in the market, and in a systematic way, and make the conclusion that, from this study, 25% of these women are obese. Now, somebody read the article now, maybe publish it, and even in Australia, now say, a study done in Africa revealed that 25% of market women in Africa, because Nigeria is Africa. So if the person is quoting from Ghana, they now say that a study done in Nigeria revealed that 95% of market women in Nigeria are obese. If somebody is quoting from Imo State, now say the study done in Southwest Nigeria, and you see, so the issue there now is that it's just the study, they collected data from only 600 people. But when they are making conclusion, they are not talking about the 600 people. They are talking of the population, general population, from where the person got the 600 people. That's what we call inference. Inference is generalization. You made from the sample about the population. So you cannot see in the generalization you make that even depend on the context. So you see some quoting from other continent, we just say this thing happened in Africa. Other people quoting from Africa, other country in Africa, we say in Nigeria. Even other people in other part of Nigeria, we not talk about the geopolitical zone of that place. That is it. So you see, even if you are not quoting from Ogun State, not say, study done in Lagos. But even Lagos, there are many local government in Lagos, and even it's not all the market. Even to the same local, maybe one local government they choose, even there are many market they choose for market. Even in the same market they choose, it's not all the women that are sample. Can you see now? So inference is generalization you make from sample to the population. So when you carry out a study, at the end of the day, that's why they talk about reference population. The population, when after you have done the work, you go to make reference to that. This study was done. So when you are making your conclusion about the population. So here now, we are talking about inductive inference. It's just the inference you made when you make deduction. When you carry out analytical study, the generalization you make about analytical study is inductive inference. While the generalization you make about descriptive study is inductive inference. So in deductive inference, we hold a theory, and based on it, we make a prediction of its consequences. We predict what the observation will be. Now, in inductive inference, we go from the specific to the general. We make observation, discern a pattern, make generalization, infer, and explanation. So that's why from here now, in inductive inference, you carry out descriptive study. What you did is you just do some cross tabulation and I say, there's association between this and this and this. So you are the association is not so. It's just for you making that, saying that, publishing that. You are just generating some theory or hypothesis. So people that will now prove the opposite are people that will pick your result and now carry out analytical study that will now prove if it is actually true, and the design differ. So look at the diagram here. You see, in deduction, you see Aristotle say theory move from theory to that theory hypothesis. When you want to test a theory, that is, we call it hypothesis, is a guess. At the time you want to test it, even somebody has established, have carried out hypothesis, it's known actually. By the time you want to see, is it actually true? Because it's after over and over, you prove theory, become principle, and become law. So at the time you want to test this hypothesis, you make observation. Observation means you carry out data collection, you collect data, then you confirm. While in induction, is the other opposite. You make an observation, just make that you collect your data, you begin to see pattern, now develop hypothesis. I think it's very, very clear. And you see the same thing, all those diagrams that just trying to explain the same thing. Now having done that, let's now talk about problem of error and inherent variability of natural phenomena. Now, for the scientists to understand the phenomenon, the world, when we talk about phenomenon here, it's the same thing as variable phenomenon. If it just a phenomenon is just a way, the whole scientific way of saying it, because when we talk about phenomenon, something abstract is there, something that is not abstract is there. For example, now, if we talk about weight is phenomenal. But sometimes when we talk about quality of life, it's phenomenal. It's variable also, but it's a construct, something that is not tangible. So when we talk about, think about any variable, think of anything the scientists want to solve. No, that is, it's just like say when you say a noun is a name of any person. Think of anything. Whatever variable you are studying is a phenomenon. Now, for scientists, these phenomena can be grouped into two types based on what we want to discuss now. Theory can be used to predict observation. The observations are not always exactly as we predict them. That is, observation, you say you make your theory, you want to, okay, what you're going to find out, this is what, you say that there is a relation between this and this. You now carry out observation. At the end of the day, you may discover that what you find may not be what you are predicted. And it's always like that. I usually give an example. Model, when you build a model, you predict. The outcome may not be socially error. Somehow that will be different. And that different. I actually use an example. If you want to build church now, you can build model, either physically or a graphic one, and they display. That's what this is our new cathedral, or this is our new campus, new site. They can design is 50,000 capacity and everything. They design everything car park. By the time they show in the church, this is where we are going. This is what God is doing, want to do now. It's a model, it's prediction, and they use that one to raise money because by the time people see people are ready to give to do it. By the time they now finish, you will discover that when they finish building that church, it will not be exactly what they show you. Somehow they cannot actually build exactly the same thing. That will be the deviation is the error. It's the same thing here in a prediction. This is what you predict, but when you make observation, it's not always like that. So this is due to error and inherent variability of natural phenomena. When we talk about error, we still have lecture on potential error in measurement. We still have that. When we talk about error, that is deviation from the truth. That is, you want to measure a phenomenon. So what you measure now, the value and the actual something, the difference is the error. If somebody, I'm 70 kg, you bring weight scale, I stand on it, you say I'm 77. That's an error. If you say I'm 70, if I'm 70, you say I'm 72. That's an error. If you say I'm 68, it's an error. Two of them, one is positive, one is negative. It's equal error on both sides, but it's either positive or negative. So now, if the observations are widely different from the prediction, the theories have to be abandoned or modified. That's what we said the other time. If the difference is too much, you have to say, oh, no, you know that it's not true. So at the end of the day, you can abandon, there's no relationship between them, there's nothing. Then you can modify. Then how do we differentiate the discordant between our prediction and the observation from the scholar due to error and inherent variability of natural phenomena which occur by chance. So there are some inherent variability, there are some error that occur by chance. Well, we'll talk about it later in another lecture. But here, for example, now, if you want to measure somebody's height, yeah, even let's say blood sugar, fasting blood sugar, you ask people to fast, not to eat from 10 o'clock, anything from 10 o'clock. Some people will stop eating from 7, but some people still eat up to that 10. They say, if you don't eat after 10. And what the type of food they eat different. The volume of, so when they now come, okay, in the morning, you are collecting blood sugar, you begin to collect, the person will collect from by 7 o'clock. If the measurement will be different if it is by 8 o'clock. The person will collect by 9, it will be different if you have collected by 8 o'clock or by 10 o'clock. You now wait on, even after 10, you don't want to collect again. You know that some of them also, the glucose will be produced from the fat deposited in the body. You know, if they are hungry, the body will be responding. It will be releasing sugar again. So in that situation, you discover that even you are trying to be stringent in the way you are trying to reduce error, but whether you like it or not, there are those errors, inherent variability. If you take my blood pressure now, say I'm sitting, I stand up, it will change. Even sitting, if you take my blood pressure now, in the next 2 minutes you take it, you may not get the same reading, because in the body, a lot of things are happening in the body. So there are some inherent variability, in measurement, and it's common with biological variable and social science variable. Anything biological or behavioral, they vary a lot. And we're going to talk about it now. Now, unlike the chemistry and physics, not that they don't vary, but even the variation is most of the time is explained at the subcellular level, at the cellular level, atomic level. That's why they talk about all those uncertainty in measurement. But you see that at the physical level like this, so most of the time they are more certain than biological variable and social science variable phenomenon. Now, how do we now differentiate that? Okay, this prediction I make, is actually not true, because I've carried out the observation, I've seen that there is a difference. It's not true. How will you actually differentiate it from when it is true, but because of some inherent variability in the measurement that make me not to predict right? It is by carrying out a statistical test, which is the test of non-hypothesis. So that is where statistics come in, to know, oh, this difference I'm seeing, is this due to chance or not due to, it's actually a difference. Because if it is due to chance, the statistic will help us, it will help us out to say, oh, this difference is due to chance. It's not a true difference. Or this difference is a true difference. It's not due to chance. Now, that is what we use statistics to do. So the variability is the variability in this phenomenon that is the need for statistical analysis. Now, the behavior of phenomenon explained by using model now, this phenomenon we are talking about, those variables, as I've explained before, they follow two types of model. This model also is just the way of explaining behavior of the phenomenon. The level of uncertainty. So some follow deterministic model, while some follow probability model. A phenomenon is said to be principally based on deterministic model. Even when the guiding theory or law is tested, the same result occurs. For example, now, Charles law, Boss law, all this law, it has, if you do it in Nigeria, do it in Canada, do it anywhere, so far you follow the same protocol, you get the same answer. So we know that water is made of hydrogen and oxygen, and test it in Nigeria, test in anywhere is the same. So if you don't get the same thing, that's why you didn't do it the same way. So it has been over and over. They follow deterministic model. Most of these variables in physics and chemistry follow this deterministic model. No, there's a guiding law. No, and it occurs. It's always like that. Now, probabilistic model. This model implies that various states of phenomena occur with certain probabilities. In biology, medicine, and social sciences, phenomena are influenced by many factors, which in themselves are variable by other factors that are undefinable. A lot of things happen. It's just like you talk about discrimination against people living with HIV. It's not the same here in America and Nigeria. There are many factors that influence that. Level of knowledge, culture, perception, many things, attitude, a lot of things that affect that, discrimination. That one is a social science, is a behavioral thing now. So the same thing, even our biology, maybe based on what the type of food we eat, the variation. Sometimes there are some, the physiology, you say that the physiology may be the same, but somehow you discover that something may work the way the body works. You respond to weather, the way you respond to weather, our body respond. In Africa, it's different from their own in UK, based on different exposure or whatever. So in biology, medicine, phenomena are influenced by many factors. In this situation where the model is principally probabilistic, that is, in case of social science and biology, where the model is probabilistic, statistical techniques are needed to increase scientific knowledge. So this is why statistical techniques are needed more in biology and social science than physics and chemistry and other physical science, apart from biology. Because when you talk about physical biology, even biology is better, is different. But when you look at physics, chemistry, the variation in the behavior of phenomena the variation is not much. So they don't need statistics. In other words, the presence of variation requires the use of statistical analysis. I think this one, just to explain deterministic, stochastic model. Stochastic is the same thing as probabilistic. Deterministic contains no random variable, has a known set of input that will result in unique set of output rather. But the stochastic is probabilistic, has one or more random variable. Random input lead to random input, output rather. Random output only estimate of the true characteristics. So the output is just an estimate. You cannot. That's why when we say prevalence of this hypertension, when you calculate, you do your prevalence of hypertension, your study, that prevalence is just an estimate of the prevalence in the population, just an estimate. But if you try to do similar thing with physical science, it is called that it will be close to even the truth. But in biological and social science, it's just an estimate. Even the estimate says, that's why issue of statistics coming, issue of 95% confidence level or interval coming. Now, you discover that over the years, the people that developed science statistics was biologists and social scientists. You heard of Fisher. Fisher was the person that developed statistical table before the computer advent of computer. Developed statistical, wrote the statistical table. He was a geneticist. Spearman, Pearson was a geneticist also. Pearson was the one that coined the word standard deviation. He was the one that first explained and discovered the chi-square distribution. That's why they call the first one to discover Pearson chi-square. So he also explained correlation. He was the one that also explained correlation, Pearson, and he was a geneticist. The same thing with Spearman and some other social sciences that contributed to statistics. Why? Because they needed, because of variability. People that study genetics, they talk about the biological variation, all those things. So they have to go into, this genetics, they have to go into statistics to actually study, because a lot of variation in all their measurement, too much variability. So statistical methods are objective methods by which group trends are abstracted from observation on many separate individuals. More often than not, the researcher is not able to carry out observation on all the units constituting a population for cost and logistic reasons. That's the way we take sample. He or she can still conduct the research by observing a subset of the population, by taking the representative sample, after which an extrapolation or inductive inference or deductive inference is made from the result gotten from sample population. The reliability of such inference at conclusion may be evaluated in terms of probabilistic statement. Because in statistical reasoning, we make inductive inference from the specific sample to the general population, statistics may be referred to as the technology of scientific method. So it's statistics that actually this technology and is used in any field. That's why you see even in the chemistry and physics, they use it. It's only that the biologists and the social sciences need it more, they develop it over the year. So statistics was actually developed by mathematicians, even though it's a branch of mathematics, developed majorly by biologists, followed by contribution from social scientists. And is used anywhere, is in any field, engineering, astronomy, statistics is needed. Because you see, when you want to measure the planetary distance between two planets, you shoot your telescope and measure distance. They take sample take measurement many a time, calculate the average. That's statistics. Because the uncertainties are still involved. So they believe that if you take the same measurement over a time, maybe 10 times or more, you calculate the average. Whatever you have will be close to the real, because whatever you calculate is an estimate, it will be the closest to the real value, which you don't actually know. So I think this is the end of the lecture. We can ask questions if you have questions. If you have questions, you can ask. You can chat also, or you can raise your hand and ask, or just unmute and ask your question. So, okay, it's very straightforward, right? No question. Or some people are just cooking, because people can just connect and cook. And if you are talking, you have to unmute. If you are talking, we will not hear you unless you're unmute. If there's no question.
But it's I think it's pretty straightforward. It's when we now get into the meat of the matter, we'll now be able to relate to this thing. But I think I understood what you're saying. It's pretty straightforward.
Okay, everybody understood. So by just wait the ground. By next Tuesday, we'll talk about those basic concepts. So somebody said, kindly throw more light on the stochastic model. Stochastic model. Okay. So the stochastic model is the same thing as the probabilistic. What you just mean by that is that model just mean that, human being form model to explain phenomena, to explain something. That is okay. Let's say this is how it looks. You now use the model to explain. If you understand deterministic, this deterministic just means that the phenomenon, like atom now, all those, I give example, Boyle's law, relationship between pressure and volume of gas is the same. Once the pressure increases, volume decreases. When the pressure decreases, when the volume increases, pressure decreases. When the volume decreases, pressure increases. So in volume and pressure for Boyle's law, they are inversely proportional. While for Charles' law, temperature and pressure, they are direct. Once you increase temperature, the pressure will increase. So what we mean by deterministic in that way is that it's always like that. It doesn't say. But it's not like that with stochastic model. Okay, for example, now, you may say sometimes in physiology, they explain that If something increase intracranial pressure, increase this one. It's not always like that. Sometimes intracranial pressure increase, the other thing will not happen. No, in biology, it may not happen. For some other factors, because there are some extraneous factors. The same thing with social science. You say that people say that why did they discriminate? You can go to a community now, maybe concerning tuberculosis. They may discriminate in one community, the other one they may not discriminate. If the discrimination may not be to the same extent. No, because it varies. If you go back to the same to measure again, you may see that the way you see that there's discrimination, you may not find discrimination. So it is so when we talk about stochastic, it means probability that the variation is too much. You are not sure that what you measure is the real thing because of the way it changes. It's not certain. The uncertainty is there. So you get to understand better when we have one lecture on their lecture on the error, potential error in measurement. I actually give that lecture before I talk about regression because it's trying, in trying to remove those extraneous factors, remove confounder will run regression. Sometimes when you want to remove all those extraneous factors in experimental design, at the design stage, you take charge of most of them. That's why you are strict about your selection eligibility criteria. You specify. That's why in experimental design, there's nothing like when you are doing random sampling in experimental design. There's nothing like that. You look for, who eligible. There are some things you write down. These are the eligibility criteria. Though you may not, after you have selected them, recruited them based on eligibility criteria, you may randomize. Randomize means to divide them into experimental and control group just by chance. That one is randomization. That one is not selection. You might have selected them, recruited them before you do the randomization. In the process of selecting them, you are very strict about the, But if you cannot do that in observational study, all those external factors are there. They will not make your study to be valid. So that is why people now do regression. So there we talk about all those errors. So stochastic model just means that the variable you are studying is not stable. If you say you measure today, you measure A, you measure even now, you take that measurement, you make an observation, you administer your questionnaire, for example, quality of life. The same people, you come back, you may not, exactly the same, you may not get it because it's about what I call behavioral issue. The same thing with biology. If I take your blood sugar now, in 2 minutes, they take blood sugar. If you can measure, you not measure the same thing. Of course, we know that the blood sugar also is being broken down. Your metabolism is taking place. So if they take within 2 minutes, it will not give you. So that shows that when they say this is your average blood sugar, this is your blood sugar. So what they give you depends on when they take it. So if somebody come to hospital, fasting blood sugar, you took the blood sugar by 8 o'clock, you will have gotten a different answer if you have taken it by 10 o'clock. You will have gotten different things if you have taken the. So at the end of the day, if you are doing the study now, take sugar from many people, you ask them to come fasting. They are now calculating the average because some people take their own by 8 o'clock, by 7 o'clock, by 9 o'clock, by 10 o'clock, different time. Some of them, if they are taking them in different time also within the time, you will not get the same thing for each of them. Can you see? So those are what we call inherent biological variability. So they are not certain. That is what you took is a matter of probability that it is the right, is the true value. That's the meaning of that probabilistic. Stochastic. Stochastic means that it's not stable. It can take any value anytime. It can give you any value anytime based on some extraneous factor. How to reduce it is subject of another lecture. When we talk about that potential error in measurement, how to reduce all those errors, we'll talk about them. I don't know if it has thrown more light now. The person that has the question. Any other one? Okay, in the absence of any other, I want to thank you for today.
Thank
So,
you.
Next, yes.